So the next talk is on leveraging AI to create demand forecasting models, automation of merchandise, financial planning and assortment. And for that we have Ms. Aruna Rajan, Senior Director, Myntra.
Hi, I'm Aruna. I am actually a data scientist, so I just wanted to have a quick shout out on how many of you from data science, so I can set a background. Oh, very little. So I'll start with my story, since there's so few of you from science. I've done a PhD in physics. I know I didn't say that to earn your sympathy, but I started in science, and in science, when we start in theory physics back, and I won't tell you how long back I went to college, the coolest thing to do was to ask, can a computer solve this problem? And then if the answer was yes, it was like, nah, I'm not doing that. That's just too simple, and I'm not touching that for my thesis. I really have to be the next Newton or the next Einstein, and I have to sit down under a tree and crack something that's really hard. And that's when I've earned my paycheck, or I've earned my non-paycheck in physics, right? But these days we're back in a full circle, and we're now at a space where people of my tribe, we go around, we get called data scientists, and the first thing we ask whenever we go see a new business is that, can a computer solve this problem? And then if the answer is yes, then I'm interested, right? So now that's what computation has come down to, where everything that you can do with a computer is now suddenly very exciting. And I wanted to speak about it in the context of retail, and I don't want to go through the numbers, but I'll put it up there for you to know. I'm specifically talking about retail in fashion, because I come from Myntra, where we sell fashion online. But any of the ideas that I discuss in relation to data science are generally applicable, whether or not, and I'll come to the fashion specific bits later. So very briefly, why should we be interested in fashion, and why should we be interested in data science? I think we should be interested in fashion because it's a $3 trillion industry. I think that makes a very good case. But what's harder to know as a group is, what can data science really do here? What can AI do here? And how can I fundamentally solve this problem differently if I think about it programmatically? Right? That's what I want to address in this talk. So let's put out what it takes to plan or run a retail organization, whether or not in fashion. How would a business person starting out or running an organization that sells fashion, what would they think about? So one of the things that they care about is, of course, how do I get customers? What are my customers most likely to buy next? What are they doing? How are they engaging with me? Some of the folks that spoke before covered this. And also, what is the content that my customer wants to buy, at what price, what's the new and upcoming content, what would they buy next, and where do I as a retailer or as a business person have my next advantage? What is it that I should be doing? And if I would like to kind of take a minute and pause on this, because these are not conventionally problems that a scientist or a computer scientist ever considered. When you're 17 and foolish, you never think that, I guess times have changed now, but back then you never thought that this was the most exciting thing to do, right? This was never considered science, and now it suddenly is, right? Now suddenly thinking about all these questions is very much in the realm of science, in the realm of programming, and that's not just because data has exploded, right? It's not just because now you're able to instrument everything, but it's because you get a new kind of value when you start to think about things scientifically, right? And to kind of drive this point, I just want to tell you, how would a conventional retailer think about these problems, right? How do people function? Retail is a very big industry. All of that $3 trillion is not yet powered by AI and not yet powered by anything very intelligent. So how does it work, right? So mostly people start planning in small pockets. If I'm selling, let's say, fashion, then there will be a category manager that sells blazers, there's someone who sells shirts, there's someone who sells trousers, and then there are people who sell formal trousers, casual trousers, and so on. And each of these people do a little bit of planning, right? Which is to say that, what are the sort of goods that I stock, at what price should I be selling them, and when should I get them to market, right? And then I will try and look at what does the customer want to the extent that I can. Sometimes I have dashboards on what's been ordered, what are things that got dropped at checkout. This is in the online space, and in the offline space, there are other things I look at. What was the traffic in my store? What were the most visited aisles, and so on. And then I try and segment my customers into personas. I say these are the types of customers that are interested in fashion all the time, and they want to upgrade their collection every week or every 2 weeks, right? And then there are some customers who only buy once, but then they want something that represents luxury, represents something that is eternal to them, right? So we try doing this the conventional marketing way, the conventional dividing users into persona and tracking their journey way. And all of this works, right? But what is special and what is different about the world of AI, or the world of, I would broadly call it programmatic intelligence. And that's where I wanted to kind of take a pause and talk about what is different in general, right? And I spoke about Newton to begin with, so I'll kind of go back there. So conventionally, you think of problems as you try and reduce the number of parameters involved, and you try and say that this is what is driving the dynamics of this problem. Let's say an apple falls down. You're trying to say that there are only two things that matter. How much does the apple weigh? What is its mass? And how far above am I dropping it from? And then I will be able to calculate a bunch of stuff around it, right? That's the conventional way to think of this, and that is very much the right way to think of this. But now, if there were a possibility to be Newton without being just as smart, all you need to do is probably fix 1 trillion cameras all around on all the trees in the world, and take 1 billion pictures every second of apples falling down, and maybe fit dynamics to this and figure out an approximate form of Newton's laws without actually having done anything too intelligent, right? So we are now able to be very less perceptive, if you will. I mean, it's not a depressing picture, it's actually very nice, that you don't really need to be very smart anymore, and you can still compute things and get them right. And I think it's a relief for people like me, who, at least from physics, where you feel like, okay, the bar is lower now, I just need to know how to compute, right? I'm kidding, but still. But what's different now is that you no longer model your system as a black box and then say that, look, I really care about how my output is related to my input, and that has to be explainable, that has to be reducible, that has to be reproducible. All of this has gone away in the new way of looking at things. And you're now saying that I just have to predict something more and more accurately, and I'm fine with that. I don't really need to explain why I predict this, but I'm fine with it as long as the prediction is as accurate as it plays out, right? And if you rethink retail in this way, then rather than trying to understand who are your customers, what do they want? Are they people who like fast fashion? Are they people who like slow fashion? Are they people who like luxury? Do you want to divide them into those conventional sexist groups of urban fashionista, ethnic homemaker, sunshine girl, and all of that? Or should you just say, I don't know anything about my customer. All I know is they looked at all of this and they went and did that. And now a very dumb machine can just chuck through millions of these data points and tell me what my customer is likely to do next. And I cannot represent my customer any better than what he or she has done on my at my retail store or on my platform. Right? So that's a new way of thinking about retail. And that's a very successful way, I would argue. And that's also why we see a lot of success in very large-scale internet retail, right? So if you think of retail as a big spectrum of either there are very small, I wouldn't call them mom and pop, but your corner stores that cater to a very specific segment and know exactly what they want. And then at the other end, there are marketplaces, there are large-scale internet retailers that probably sell you anything and everything you can find in the world, right? So when you're working at that large a scale, it is actually possible to model customers as nothing but a series of transactions, and transactions can be purchases or browse or actual things you've done on the app. But when you are somewhere in the middle, which is where most of us are as retailers, where you're not listing everybody and anybody on your platform, and not anybody and everybody is buying everything on your platform, then how do you rethink this? And why is that extreme easier, and I say easier with a qualifier because it's the classic programmatic case where you're saying that depending on what my customer has seen, I predict what my customer is able to do next, right? And that becomes very doable now programmatically. If you have a lot of data and a lot of customers and all of them doing many things, I no longer need to really understand retail. All I have to say is if you've clicked on something, you're likely, let's say there's something that I have text description for, you sent me some text and then you clicked on something. Now I know that the text description of whatever you clicked on is related to the text you first put in when you came in, right? And this helps me not just relate what you are saying to what I have, but also find semantic meanings and mappings between these. And this is a very powerful technique that works at large scale. And what I wanted to talk about for the next 3 minutes is how does it translate to a scale where you actually are mostly privately owned labels, privately owned brands, and then a portion of you is also a marketplace, which is where I think the large retail spectrum lies today, right? So things become much more complicated, and I would say that's because, let's say you want to plan demand, let's say you want to say, what is my customer thinking of next? Then it's no longer possible to answer almost 90% of your questions with just plain looking at what they did, trying to model it, and trying to predict what comes next. Your accuracies on that are very poor. If people have, since most of you are not from data science, I won't dwell on that, but I'm happy to take questions on that later. So what are we doing differently at Myntra to address, let's say, the demand forecasting problem, which is nothing but a fancy way of saying, what is it that my customers want to buy? Right? If I have inventory in fashion, what should I stock next, and how much should I stock, and what conversion should I expect? Right? We are trying to look at this from first principles, which is saying that fashion is represented by the images that you see. It's represented by the tags present on these images. So first, as a computer program, can I understand what does an image speak to you when it is out there and when you're looking at it to buy? So one of the things we do is to extract catalog or fashion attributes from an image that look like this person is wearing a blue shirt, it's a solid blue shirt, it's something you wear outside of your, it's something you wear on the outside, it's probably a jacket, he's also wearing a scarf, and he's also wearing something that's long sleeved. Right? This is all completely programmatic, and it's now possible to do. I think Aniruddha spoke about face detection. It's now also possible to do what exactly you're wearing detection in this language, right? Now, the next thing is this language adequate? And to kind of illustrate this, while we are able to extract attributes or fashion features from images, and we're also able to compare two images for their fashion features, what I'm showing you on the screen is a celebrity wearing something that's clearly fashionable because it got a lot of eyeballs, it got a lot of tweets, a lot of people talking about it. So as a retailer, if I say that Pariniti, who is on the left side of the screen, is wearing this particular ensemble and appearing at a red carpet event, can I very quickly look at what is it that I have in my inventory that matches what she's wearing, and can I promote this and thereby make people buy this? Right? So if you totally do this programmatically, what comes up on the right side are the set of dresses that the computer thinks are similar to what Pariniti is wearing. Of course, if you're fashion illiterate like me, then you would say that, oh, I'll live with that. You know, that's more or less what she's wearing. But if you follow fashion, and that's our customers, you clearly see that you can tell why the machine thinks these set of images are similar to what she's wearing. But you can also very easily say that they're not at all the same, which is that the image on the left and the images on the right actually speak very differently to you. So fashion is not just a set of collection of pixels and how they're arranged amongst themselves, but it's also a language. When someone is wearing something, they're speaking to you a certain way. So the next thing we're trying to do is to understand the language of fashion. So when Pariniti is wearing that, what is the sense that you get? Is it chic? Is it the modern woman not unafraid of rebelling against convention? What is that in that image that speaks to you and makes you want to wear it, right? And that's not the fact that it is green and has 6 buttons and has a collar. So we're trying to reimagine fashion in terms of understanding images as things that speak to you, understanding apparel as things that speak to you, and then trying to trying to model demand at that level. Like, what is the demand for something that is quirky as opposed to something that is classic, conventional, or something that you could bear to work, right? And on that, I wanted to also quickly tell you some of the things we're doing. This is an example of, and this is to sort of illustrate the power of AI, which is, it is like teaching your child to make a dress. I'll just take a minute more. It's about saying that, hey, I don't know anything about a fashion as a machine, right? But can I still make fashion? Because I seem to have understood what my customers want. If I'm able to sort of model demand at the level of an attribute that people care about in fashion, am I then able to also generate fashion? Can I speak to making fashion? So it's sort of like teaching your child to draw the picture of a top or a shirt, right? Or a cat or a dog. So they just start with random squiggles of what they think represents a cat or a dog, and then you keep saying, no, this is not a cat, this is not a dog, try again. Here's a picture of a cat for a reference, and they still come up with something that somewhat reminds you of a cat. So if you sort of thought of the computational problem in that way, that can I start making random squiggles, and then tell my program that this is how a shirt is supposed to look, and can I create variants of a shirt, which is that in this particular experiment, we tried to add quirk to checks or quirk to prints on dresses, right? And what our methods do is that you can see that what we come out with are not your regular stripes, they are not your regular patterns, but they are kind of distorted. But they went through, as in the program learned to say that this is an acceptable t-shirt or this is an acceptable dress, while it really didn't know what these things are. Right, so that's some of the flavor of what we're doing, and to kind of come back in a circle, we are kind of trying to understand what is it that people care about when they buy fashion, and it is this particular attribute that we really need to understand in time over sales or clicks or each of these, which only give us, let's say, about 70% of the picture. What is it that drives variability in a space like fashion, where marketing and where advertising drive content consumption? And what sort of pricing interventions are kind of usable in this scenario? What would you like to pay for something and that Pariniti is wearing? If I just give it to you now, would you pay more, versus if it came a week later, how much would you pay? And would each of you pay differently? And is it fair to price it differently for each of you? So these are the kind of things that we deal with, and these are the kind of problems that are at the intersection of fashion retail and data sciences. And I'm happy to take questions on these later.
Thank you so much, Aruna. Thank you so much. There's a small token of appreciation from our side.